Okay, welcome America, welcome Justin Bieber, and welcome India to the Pythagorean Theorem notes. So this is basically just an introduction to Pythagorean Theorem. You may have seen it in 8th grade, you may have seen it at the beginning of the year, and we're just gonna brush through it again because it's an introduction to trigonometry, which is really, really important, and probably the most useful unit that we're gonna learn all year in geometry. So here we have a right triangle, okay? We know it's a right triangle because we've given this little box right here. The side that's across from it is called the hypotenuse, and these are the other two, these are the legs. The formula we're going to use is the c squared equals a squared plus b squared. So really what that means is that this area, if I make this into a box, okay, pretend like that's an actual box. This length is c, this length is c, so this area is c squared. That area is equal to b times b, this area, b squared, plus this area, a times a is a squared. So this area plus this area adds up to this area. And that's all the formula says. Back up. So we are going to use this formula to work backwards. So for example, it's really powerful. Let's say you get a right triangle where you know the length of the two legs, but not the hypotenuse. We know this is the hypotenuse because it's across from the right angle. We can use our formula, and we need to make sure that we plug in these lengths, 21 and 20, for A and for B, and not for C. Guys, please. So when you do this, I plug in 20 for A and 21 for B, okay, and this becomes c squared equals, and I'm using a different color, but that's okay. This is 400 plus, was it 441? Together, those, you have to square these two numbers first. Okay, then you can add them together. So c squared equals 841. And then to find c, we have to take the square root of both sides. Now we know how to simplify radicals now, so we want to not write this as a decimal like we did before, and we are going to be simplifying radicals. In this case, this is a perfect, is this a perfect square? I wrote approximately, all right, we'll leave it as 29. Okay, this side, we have to be very careful because they have given us c. So we have to put the 20 in for c. The other legs are 8 and x, and it doesn't matter if you put in 8 for A, if you put it in for B, either one is fine. So I just wrote B, you could put x, either way, these are the legs, and that's c. So when I square these numbers, I get, this is 400 equals, this is 64 plus b squared. Now we have to isolate this b. So we're going to subtract 64 from both sides. And when we do that, we get x squared or b squared equals 336. When you take the square root of both sides and you simplify that radical, 336, I'm running out of room, the square root of 336 is actually 16 times 21. So when you pull the 16 out, the square root of 16 is a perfect square. That becomes 4 root 21. So that's the length of the side, 4 times root 21. For the next two problems, they are practice. I'd like to see if you can do those on your own. If you did them right, you would get C is 5, and you would get B here is 12. Make sure when you do the Pythagorean theorem that you put in this number for C. This is going to be 13 squared equals 5 squared plus b squared. And this side's going to be c squared equals 3 squared plus 4 squared. Stop the video and see if you get 5 for your answer. And don't forget to take the square root at the end before you'll get c squared. You need to take the square root to get the value for c, the length of the side. All right, moving on. Now, can we check to see if the triangle is a right triangle? Sometimes we're given a right triangle and we're asked, is this a right triangle? Well, all we have to do is see if the Pythagorean theorem works with these numbers. So in this case, the longest side is 85, so that has to be our C if it is a right triangle. So I'm going to put 85 squared. Does that equal 13 squared plus 84 squared? I don't know. We're about to find out. This is 7,225, and you're using your calculator. And this is 169, and this is 7,056. We take those numbers, we add them up on our calculator, and we see that 7,225 equals 7,225. So therefore, boom, it's a right triangle. Okay, so now there are two other possibilities, right? C squared could be greater than a squared plus b squared, or c squared could be less than a squared plus b squared. And here's what happens with those. And this is new. If you've learned the Pythagorean theorem in 8th grade, this is a new concept. So c squared, if the area of c squared is bigger than the other two areas, then the triangle is going to be obtuse. Think about it like if you've got an obtuse triangle, I'll just draw it here. This area is going to be really big. There's your c squared, right? And these are going to be smaller. So when c squared is greater than a squared plus b squared, it's an obtuse triangle. Okay. However, if I redraw that triangle and make it cute, okay, where c squared is less than a squared plus b squared, I'll just make it like this. Okay. So here's your c squared. Oh, this is terrible, but if that area is less than those two areas combined, then it's going to be an acute triangle. So we can use that for examples 4 and 5 to determine whether the triangle with the given side lengths is acute, right, or obtuse. When we're given 3 lengths, obviously the longest side is our C, so we have to make sure we put that in for C. So here we're going to do 15 squared. Is that greater than, less than, or equal to 12 squared plus 13 squared? And here, the longest side has to be 14, so 14 squared. Is that greater than, less than, or equal to 6 squared plus 11 squared? So you have to square each of these numbers first before you can do anything. This is 225. I don't know what that number's there. Okay, and this is 144 and 169. So then you take your calculator out. You see this is 225, and this is 313. So 225 is less than 313, so that is an acute triangle. Acute. Okay, this side we've got 196, and then we've got 36 plus 121 for a total of 157. 196 is greater than 157, so that is an obtuse triangle. So if c squared equals a squared plus b squared, it's a right triangle. If c squared is less than a squared plus b squared, it's an acute triangle. And if c squared is greater than a squared plus b squared, it's an obtuse triangle.